Okay, so we're recording the progress on the distributive 3D printer enterprise. We have a call with Torbjorn, and Jonathan has joined us here, our community manager. We're talking about Prusa i3 as the machine we'll go for with the first workshop as we develop OSC's version of a scalable, fully scalable, better quality actually for the purposes that we need, and large enough for doing things like printing 4-foot wide polycarbonate glazing or car body panels, things like that, or worm composters and black soldier fly chambers, things like that. But basically a larger, scalable, highly flexible version. I don't know if you might have seen, Torbjorn, the roadmap on the 3D printer, but also the scalability or modularity would mean that we can put all kinds of heads onto that. So just for your reference, the roadmap page on the wiki, if you go to the 3D printer roadmap, under the full modularity and product ecology achieved part, there's a notion of all the different kinds of heads that we can put on it, up to things like laser heads or paste extruders for ceramics, things like that. Okay, so now we're evaluating the Prusa i3, the page on the wiki called Prusa i3 development, and that means adapting existing Prusa, which right now we get a kit from Folger Tech. You can see that here on the wiki page. We're evaluating that to see how well it works for a workshop and what improvements we want to do to make it better, and include at the same time as many of the components that we will use in our final OSC spec machine in this current build. One thing we're looking at right now is automatic bed leveling as a really important feature to make it super user-friendly for beginners who don't have to mess with even leveling the table before they're able to print. So we're looking at right now Jonathan and Torbjorn, after our evaluation build, which will happen next week, Tuesday or so next week. We're going to build that at Factory Farm, myself and Alec. We're going to report the learnings, take pictures, take documentation, record what we can as far as how suitable that is, that current Prusa i3 from Folger Tech is for the workshop. Because some of the critical parts will be how good is the part sourceability? Is the thing actually working? Are all the parts reliably produced? So really working out the details of, can this be taken to an enterprise? And that's where we are right now, discussing this. Now also we have Joshua, who's involved, who's going to be involved in organizing this a little bit, and maybe we can direct him as well to if the printer works well, to also get involved in sourcing the same kit to experiment and help us develop that for the workshop. The workshop right now is planned for March 19. That's our current deployment date. That's all I have to say. So where are we? Where else are we right now? So Torbjorn, Jonathan.
Mm, Regarding the 3D printer bed leveling, I actually did a bit of research the other day. But I think I forgot to post it. Let's see. It's an article there that steps through the entire state of the art. Very helpful.
Excellent.
So I landed on a force-sensitive resistor solution,
Uh-huh.
and I would prefer to have it near the tool head and not in the bed. Because if you have it in the bed, then you lose scalability, because you need to have a wire going into the bed, and if the bed moves, then you need a very long wire and you're limited. But if you have the sensor in the print head, then you can scale up.
Mm-hmm.
And you can also probe anywhere on the bed if you have the sensor in the head. You can probe more than 3 points, potentially.
And how does it work?
in the corresponding resistor into the Arduino, and you have some code that with a threshold value appealing when you have pressed when there's pressure on the printhead, and then you have some simple routine walking around the bed and counting Z steps.
The pressure from the stepper motor, so the resistance of additional current to the stepper motor, or how?
No, you force the hot end into the print surface, and then you have mounted the force-sensitive resistor in such a way that it feels the pressure.
And where is that resistor located?
You need to locate it somewhere near the printhead in a smart way so that it gets squeezed.
So it actually gets squeezed and it gives you a different threshold current through it, or resistance through it?
Yeah, it changes resistance when you squeeze it.
Mm-hmm. So that's like a piezoelectric?
I don't know if it's so, but I would guess something like that.
Okay. So
pressure resistor? A pressure resistor?
Yeah.
the article which article I see, the 3D printer improvements page, which of those links?
I can post the link in the chat. It said 3D Make, the first 3dmake.com link.
That's good, okay.
It's a French hacker guy who's really talented wrote this.
Force-sensitive resistors, yeah, there's pressure resistor.
Yeah,
Okay.
yeah, force-sensitive resistor. Kind of expensive.
Are they really?
Yeah, $5-6 each.
Wow.
That's also a reason to have it mounted on the printhead somehow.
Mm-hmm. So just for collaborative literacy here, so I'm putting the link to the printer bed leveling industry standards in the D3D industry standards page in the development spreadsheet, where the development spreadsheet is on the D3D development page. So good. The article that actually discusses this, is that the only? Can you point me to that's the product? What about the actual article that discusses this?
What you mean, the blog post I was talking about that steps through the state of the art?
I see the 3D printer bed leveling page. What about some discussion of the pressure sensing resistor?
It's in the... you mean something that I wrote?
No, where'd you find out about this?
I found it in the link that I posted on the chat right now. 3dmake.com 2015.
Okay.
Well, bed leveling trim sensor.
Okay.
It's kind of a long article.
Let's see, it has a link to the SparkFun part.
There?
Yeah. Let's see. So Force sensing resistor. Okay. And it's sensitive to within plus minus what distance?
It depends on how we mount it. So it's sensing force. Let's see the SparkFun page. It sends applied force anywhere between 100 grams and 10 kilograms.
Of applied force, okay. So that means we get a stiff, we have a stiff bed that it's not really spring loaded because the springs would get rid of that accuracy maybe, or so a stiff bed, and then you adjust the code. In the code you basically subtract the plane of the bed based on say a couple of 4 probe points.
Yeah, or the firmware usually apply a rotation matrix on every single G-code line.
Okay. Have you run into what are your thoughts on the ones that are simply by touch, by electrical closing an electrical circuit? What are your thoughts on that one?
They're very elegant. And it's potentially very cheap, but you need to have wires in the bed.
Yeah. Which works well for the stationary bed version, right? But not for a moving bed version.
It works well in the range that the bed can move. But it's a scalability issue.
Yeah. Okay. Have you seen documentation of these? I mean, when you say potentially easy, have you gotten a feel for what the state of art is in that, how easy it is to replicate that? I mean, that sounds like, yeah, it's really have to evaluate these options in detail. So, yeah.
Yeah, I'm quite sure I can implement it, but estimating time is kind of hard.
Right. Maybe the way to refactor this applies to D3D, right? This is whatever we decide here will probably be transferable, or we consider D3D in that process. So maybe the next step on that would be to assess, so take all the choices so far, maybe do a matrix of, okay, here's the advantages, disadvantages, cost, and effort estimations for each, something like that.
For each bed ramming solution?
Yeah. Yeah.
Yeah, it's kind of already done in the article I linked you
to. Which of the articles?
3dmake.com 2015-12.
Okay.
It's stepping through in like natural language, not the matrix format.
I put it on slide 3. Excuse me, it's slide 3.
Slide 3?
Yeah.
Okay. Oh wow, nice.
Look at that. We've got some collaboration happening. Jonathan's a veteran. Yeah. Okay, so the longish article discusses that.
Yeah. As the tech tree, it steps through the tech tree of choices, discussing advantages and disadvantages. Yeah, and the guy also implemented a a bed tramming solution himself.
What's tramming?
Tramming, it's bed leveling. Bed leveling and bed tramming are kind of the same. I've seen people build force-sensitive resistors themselves with conductive foam.
Mm-hmm.
So that's possible. But what do you guys say about the LCD screen on the printer?
Well, the present kit, I believe, comes with it.
Yeah.
Well, I mean, we'll get the data when we do the build, right?
Yeah, we will.
And we can talk about options as far as the base kit, like for the workshop, includes that, it doesn't include it, whatever it includes, we can make those decisions based on costs and performance of those things. Okay, so scanning through that article, it doesn't say much about, well, I mean, kind of looking at it, I'm not getting a good feeling for the amount of cost, time, or ease for each option. It's kind of saying, okay, these are the options. Somewhat talks about it, but not. I think the next step would be refactoring that for our considerations. Or what do you think? What do you think we should do next?
Me?
Yeah.
I think we should just try to implement, build a prototype and see if it.
Which one? You're suggesting the resistor?
Yeah.
We have a auto-leving inductive proximity sensor on eBay for 448. Slide number 4 just put a link to that. I don't know if you've referred to that or not, but
Yeah, lots of printers use those.
I'm sure you've probably seen that one, but
Yeah. Let's see.
Sounds.
Why? It's a non-invasive measurement technique, so there's no touch.
I would say there's probably accuracy issues involved with that. That doesn't sound. I mean, what are the pros and cons? Do you think accuracy is really good on those?
probably not.
I know it's good enough, but you must have metal below your printhead.
Mm-hmm. So an aluminum bed, for example, would aluminum work?
Yeah, aluminum is what people use. But yeah, it would create dependency, extra dependency. So bed level is dependent on bed material. I don't know if we want to add that dependency. Usually you just have glass print bed, especially if you don't have heated print bed.
Sorry, what was the comment on a heated print bed?
A heated print bed usually has a heat spreader, a flat sheet of aluminum.
Mm-hmm.
But printers without heat bed, they don't usually have aluminum print beds.
Right. Yeah. If the surface is glass, this doesn't work. It has to be directly on. If there's aluminum below that, can that still
I'm
do
not
it?
sure.
Yeah. Yeah, I think prototype as well as, I mean, under test-driven development, go to the hairball of various potential steps to evaluate, and I would say you would prefer prototyping at this point the touch sensitive, pressure sensitive resistor.
Yeah, I would. Just because if it works, then it's the best solution.
Because what?
And if it works to have just one sensor and basing it on actual touch and force would be best.
Mm-hmm. Okay. Yeah.
And if it doesn't work, then we will see when we prototype it. Using actual touch and force also makes the bed leveling mechanism independent of print head length. If we want to change print head or mount another tool.
Sure. Right. You want to? I mean, maybe we should. I think it would be useful to determine some criteria for our selection.
Yeah, we should maybe write down all these arguments somewhere.
Yeah. That's what I refer to, like a matrix of comparisons, pros, cons. Let's see. So maybe let's start that on slide number 6. New slide.
Okay.
You got infrared, mechanical, capacitive, inductive, and ultrasonic. You got quite a few.
Yeah.
This way we can get feedback on it as well. Whether our assessment is good. Comparisons of let's see, what's a good way to do that here?
Yeah. We want to categorize based on where the sensors are placed and what kind of sensor it is.
Okay, there's two types of open short circuit. There's another one where it's just a press on the bed, and a connection is made or broken not between the print head and the metal, but because you're making and breaking some connection under the bed. So
Yeah. Yeah. Okay.
Can we say like under bed, under sprung bed? It's got a spring-loaded bed.
I think the one that the low spot uses, I would call maybe potential difference between print surface and print head.
Potential difference isn't okay.
Undersprung bed electrical make free. Okay, then this first would be called
Some guy's using a piezo disc, which is
so what you say?
some guy is using it from Norway is using a piezo disc.
Yeah, yeah. Column with OS support available is not really relevant.
How come?
All firmwares for all types of sensors. Just need to specify what's a high and what's a low.
No, but I meant just for the technique, not on the software, but overall. I mean, just support available for implementation. Like, if we find who's done it, do they talk to you?
Ah, okay. Yeah.
For build. Does who built it talk to you? Is builder open? Tilt print head. That's the first one. So
Yeah.
the breakage of the contact is upon tilting the head?
Yeah.
Okay. So I'm gonna put a slide before that, and I'm gonna go requirements, mechanism requirements. For example, I would put any mechanism that requires movement of parts should be avoided. Like, for which reason there's a simple contact, like you've got this contact on the disk that you talked about on the resistor, that would classify as good. So we're going to say optimal solution should be because any additional movement, so it would require no additional movement, because any additional movement means that's a feature that has to be built into the hardware. No additional movement of parts. That's an other than what the printer already goes through in normal operation. I mean, obviously low cost, easy to build, has good support, reliable. To what are the specifications there? To 1/5 the height layer thickness.
Yeah, you have a precision parameter, and you have also repeatability. Some solutions will be very precise for 10 prints, then you have to adjust them. And some of them are kind of precise forever.
Yeah, so I would say reliability would this be good? Like, for example, 1/5 of layer thickness plus minus 50% of that layer thickness? Do they have figures of merit that anyone uses, or? I would say 1/5 the layer, that would be kind of like what you definitely would need. Maybe it's even 1/10 the layer thickness. Well, we can ask Lozbot what their algorithm is. What is their design for the accuracy imposed upon their bed leveling mechanism? Yeah, that would be our test-driven design here. I'm gonna I'll email Jeff right now. That would be a good thing.
Yeah.
I mean, they're doing it. Theirs absolutely reliable. I've never had any trouble with bed leveling on this machine. I turn it on and the thing prints. So we should learn from these guys.
As long as you never have plastic between the printhead and the bed, then just closing this like that is very, very precise.
Right, and that plastic, they do it by scrubbing the head on something, but I think that also could be done by the design of the nozzle, or something where it would actually require modification of the nozzle head, but it's not the nozzle, but something equivalent to the nozzle hitting like a little a probe that's just attached to the head there. Or it's such that when you touch down, because the plastic is molten, it should not interfere with the making of the contact.
Yeah, that's the good thing about using force-sensitive resistors, because then you will just pressure through all the molten plastic.
Yeah.
If you're relying on electrical contact to something that's not the nozzle, then you need to have an arm sticking out that's above the nozzle height, and then you risk having the nozzle running into that thing in the bed that's sticking up.
Yeah.
Yeah, you need some structure that is higher than the rest of the print bed. If you're not going to use the nozzle as your sensor, like low spot does.
Yeah.
So it creates its own problems.
Right. I think one of the main figures of merit here is we should add a column to this accuracy and repeatability. So we should have a number. I think that's the most important figure we need in this table. Well, if we're going to do it properly, we would need that.
Yeah.
Let's see, how do you add a column?
We need
insert
a larger matrix because there's so many solutions.
Yeah, can we just reduce the text size on that to about 10 and then add a couple of columns?
Yep. Let's see.
How do we add another column there? Oh, simple right click, insert column right. Okay.
Is it proven? Do we need that?
Yeah, I mean, I think the
proven
comes out of examples.
Yeah, exactly.
And whoever put early smart friends, can you put a link to that? So link.
Yeah.
So that figure should be, so accuracy and repeatability should be microns plus minus percent of that. Percent of that base. Yeah. So you don't really want to say layer thickness. Yeah. For us, it could be like 1/5 the layer thickness, whatever our layer thickness is, but that has a value to it.
And we want it in millimeters.
Don't you want it the same unit as layer height?
Yeah, layer height is also in millimeters.
It is? I thought it was typically microns.
Yeah, okay, yeah. Microns is fine.
So 1,000 microns is a millimeter.
Yeah.
So 100 microns is 1/10 a millimeter. That's kind of like I've seen the best printers get like, I think some of them go to like 20 microns, which I don't know how meaningful that is, because
they say 20 microns precision on all the axes.
Yeah, it could be that, because of course the thread itself is going to be on hundreds of microns.
Yeah, they just throw out a number because it doesn't make any sense.
Yep.
To say 20 microns here and there. If you tighten the belt, then you have 50 microns, and then you lose a micron every day. It's just complicated. That's kind of why I want the lead screw so much, because it's much simpler to
Sure.
specify position.
When people talk about reprogramming, do they talk about reprogramming the software or firmware here?
It's just one piece of software, and that's the firmware.
Sorry, one piece of software and what?
It's just
It's just
yeah, it's the firmware, the program that's on the printer itself.
Okay. So is a requirement, or is this automatically taken care of, that you don't need to reprogram the I'm not familiar with the tool chains enough. I mean, there's the program that's on the firmware on the printer itself. That's what you need to change, but you don't. But also things like configuration files. Is that you're considering that as part of the firmware?
There is a configuration file for the firmware, and then there's different configuration files for slicing. So you would need to change the firmware configuration, but you can keep all your G-code and stuff.
So I think the requirement specified is does not require modification of slicing.
Yeah.
Because I mean, I'm sure there could be some other modifications that would require that.
Yeah, it could.
So we're not going to change the slicing unless we need to, unless we see a reason for that, which we don't. What else? Let's see. I think I need to get going like 2 p.m. here, so maybe we could start wrapping up. But so we've got the requirements for bed leveling. Maybe we can finish off on that. And the next step would be to look at evaluating the implementation of that, especially after we see the build itself. I mean, it might turn out that we're struggling too much with the kit itself, and we won't have enough time to implement the bed leveling. I mean, it's a hope we have right now, that we would definitely, if we don't have too many troubles with the build itself, right?
Yeah.
Mm-hmm. Yeah.
I kind of have really informed expectations about what you will meet when you build the kit.
What are your thoughts? You think it's gonna be hard?
I think you will spend a lot of time trimming the trim pots for the stepper drivers. And also you will spend a lot of time getting the wires right. Just plugging in the wires takes almost half the time, usually.
Right, but is that because of lack of documentation, or because of Because of the number of steps required.
Because it's usually saved to the last step when there's wires all over the place. So you get confused and yeah.
Do you have suggestions for keeping better track?
Yeah, we should really do cable management continuously during the build.
Okay, so
And
maybe
also,
before.
we should find electronics that don't require users to touch the trim pot and risk ruining the motors and step drivers. You want the software to handle that.
Trim pots on the ramps? Is that?
Yeah.
So in other words, we don't. You're suggesting we don't want to use ramps.
Yeah.
Mm-hmm.
You want another electronics kit.
Yeah. So offhand, we're probably expecting that because this comes with ramps, right? That's what we're.
Yeah.
Let's see. Let's see what it says there. Under kit page. So we're pretty much saying, unless we figure out a, yeah, okay, that sounds. I think what you're saying right there is. We need to simplify all those steps.
But I'm really interested in how much fiddling it takes to get the LCD screen running, because I haven't done that myself. So I'll have to trust your opinion on that.
Mm-hmm. Let's see it. Let's see, Folger Tech. I didn't even document the link on the Prusa page. Okay. So here's the link. Folger Tech kit. I'm gonna put that as a link right on Folger Tech. Okay, so if you refresh the Prusa i3 development page, Folger Tech Kit is linked right to the title there. So it says it's got the A4988 stepper drivers. How do we know that? Okay, ramps 1.4. There it is.
That's the most usual and the weakest and the cheapest electronics available.
Yep. So we're probably expecting to excise those. Do you see any promise in that, or you don't see any promise around the trim pots? Around that, how much time does it take currently to do that?
To do the trim pots?
Yeah, what's the process there?
For me personally, the first time I did it, it took like 2 hours.
Whoa.
But to do it now, it takes maybe half an hour if I have to look up documentation, which I do every second time. And without documentation, it takes 15 minutes.
15 minutes?
Yeah.
What is the process required? So you adjust it, and then what do? You run the motor?
You have, if you have an assembled printer, you first need to unplug your motor, and to unplug your motor, you need to power down your printer. So power down, unplug the motor, and then you power it up again, and you take multimeter and measure a voltage. And then you go calculate which voltage you want by looking at the motor spec, and at the stepper driver spec, matching those, finding the right voltage. Then you start screwing on the potentiometer. Then you measure the voltage between the
Oh wow.
again to see what voltage you have now, and then you do it again and again until you're at the right voltage.
Okay, forget about it. That's absolutely unacceptable for this kind of workshop. So yeah, we'll have to move beyond that. What are some examples? What's the board that doesn't do that? Doesn't require that?
Rambo doesn't do that.
How much is that over the existing system? How much price would that add?
Oh, totally depends. I bought one from Machine recently, and that was really expensive.
Rambo, not this Rambo. Board. Let's see. Whoa, they're like 128. There's $80. They're $80, 75. 1.2G. Yeah, what's version 1.2G?
Okay, Machine sells 1.3. They are the ones who created the Rambo, so they're the highest quality source. They're also expensive.
Mm-hmm.
Yeah.
Okay.
You know the Troublemaker?
Yep.
They swapped out the Rams and used Rambo instead.
Yep.
Because of this.
Yep.
But there are other electronics kits with digital print box.
And the detection happens, you actually detect the voltage requirement, or you still have to set it manually?
You just specify the voltage you want in the firmware, in the code.
Which can be automatic based on a reliable source of the steppers.
Yeah, when you know which steppers you use.
Sure.
You can find the right voltage and just punch it into the firmware and upload the firmware.
But hold on, if you have, say, a NEMA 17 stepper, they operate at different voltages? They're set for...
Yeah.
What's the range? I mean, from 12 to 24, or like what? I mean, well, you can...
The important is really to not send too much current through the stepper motor.
But aren't those, like, say a NEMA 17, aren't those all identical, or that's just the housing size? It can be different inside.
It's the housing size, yeah, or the housing area.
Okay.
So NEMA 17 is just an interface for 4 screws.
Okay. All right. Okay. Good to know. So I won't get troubled by that when I get to that. I didn't know that. Okay. Okay, so we're gonna have to pretty much, before the build out, we wanna think about how we manage the... Well, we should probably just build it and go through that, unless we refuse to. Let's see, is it worthwhile to go through that if we know we're not gonna use that? I mean,
yeah, it is. I think it is.
It's worthwhile?
Yeah, you learn a lot.
Okay. I think we might have to feel the pain. Yeah.
Not that bad. You can always ask me.
Okay. Alright, so we'll probably plan on doing a complete build. And that's actually good data. That's good data for your thesis.
Yeah, it's very good.
Excellent. Okay. We'll squeeze our blood for your thesis. It's worth it.
It's very nice. I'm grateful.
Okay. Okay, I gotta get going here, but let's see. Do we have enough to go on? So we went through some of the requirements. We can keep refining the requirements as we get better at the technique, because actually requirements are kind of iterative. As you find something, you find out, wow, I actually need this too. But I think that's a decent start, saying basically that we require no movement, no extra movement, and no physical modification outside of adding a sensor
Yeah.
of some sort.
When you say adding a sensor, then it's only one sensor.
Yeah. Low cost, easy to build, easy to program, has good support in terms of builders, in terms of others who've built it. Like for example, Lulzbot, we can borrow that, man. I mean, they've got the whole system worked out. If we want to simply say, oh, okay, we'll do that because it's absolutely proven and it absolutely works, that's one route to go. Or we can say we'll experiment looking more, but we know there's a solution right there that does work, and it might be worth considering.
Yeah. On the other hand, they're the only ones who use that particular solution.
Oh yeah. Okay.
There's really lot of solutions available.
Yeah. Yeah.
But they're definitely the most elegant one, I would say. But yeah, other people have researched into it and chosen differently, so we should give other solutions a look as well.
Elegant because of user friendliness or actual implementation?
Because it's so accurate and it looks good.
Yeah.
And it doesn't. On the other hand, it requires many parts and a bit of extra programming.
So another requirement would be it adds little to the printing time. Thing about the Lulzbot thing, it does take. It's acceptable, but it does take a minute or so to do. Minute or 2 minutes.
Well, okay.
I mean, there's the whole rubbing of. I should actually measure that and get the data point, but it rubs the head a few times. It takes like 10 seconds. Then it goes to each corner. It goes up and then goes down very slowly for 4 corners. I think it adds up to like 1 or 2 minutes. So
okay.
It's something to consider. So we want to add as little to the print time as possible.
Yeah. That's true.
Mm-hmm. My industry standard is whenever we get serious about a topic, I change it to Arvo, which is our official public font. All right.
Okay. I really look forward to hearing your opinions about the kits.
Okay. Yeah. No. We really look forward to doing that. See what really happens, and we can deploy the armies of Jonathans, Joshuas, and Torbjorns and others to. I mean, we can start inviting people to this development process. It's good.
Yeah.
We have still to build a team.
Yeah.
Mm-hmm.
Okay.
All right. Great work. So we'll continue. So when do we set up the next time to talk? Do you know right now, or you want to just email me when you're settled?
Let's see. We'll have an apartment. Maybe we will have internet about Friday. We could say Friday, and then you can be in contact.
Okay. So Friday, same time, 1 p.m. our time here?
Yep.
Okay. I'm going to put it on the calendar right now. Let's see.
Friday is 29.
Friday the 29th. I'm talking to Yorick next week, so I'm going to get possibly some insights into the libraries, how to create a workbench for the 3D printer in FreeCAD. Yeah.
Yeah.
So 1 p.m. All right. Excellent. So we'll talk to you Friday, the 29th.
Yeah. Good luck with the kids.
Yep. And you're pretty much in transition, or are you going to have any time during the next few days to do some work still?
I might, yeah, I have a couple, maybe 3 hours tomorrow, but I only have a computer and an empty apartment.
Mm-hmm.
So I'll probably do some coding or something.
Yeah.
And yeah, I will have like half an hour here and there with the computer.
Yeah. Um, what's your priority in that time? Could you maybe work on a table of comparison of auto bed leveling systems? We can keep working on that. I'll ask Jeff for some insight and so forth.
Mm,
Or you
I
got
could,
other stuff.
I can think about it and send you an email in half an hour.
Okay.
Yeah.
Sure. Excellent. Okay, so we'll talk on Friday then. And
Yep.
yep. Take care then.
Okay, take care. Bye bye.
Bye bye.
Sure. Bye-bye.
Okay, Jonathan, I'll hang up too, yeah?
Yep, sounds good.
Okay.
Good talking with you.
We'll keep talking. Okay, bye bye.